What I'm doing in the last lecture is to do something which I think would make any course on finance incomplete, and that is to discuss sustainable finance. I'll explain what I mean by that. In this course, we have seen a lot of different things, from basic math to finance. We've priced derivatives, we've priced bonds, we looked into stock processes, all sorts of things. Many of these things have been developed over the course of the 20th century. There's many things that we did not cover. We did not cover some of the techniques that are more involved with machine learning, for example. We did get a glimpse of that in one of the lectures, but that will come later when we talk about machine learning and data science in a different course. What I want to do today is discuss how finance in a social context is developing. And it's something which is not entirely new. In fact, I will show you how, in my opinion, this thing started like 40 years ago. But it's picking up speed and it's becoming a source of revenue and profit for the financial sector. And that means that if it becomes a source of revenue, then it's here to stay. And I want you to be aware of that. I will talk about a number of social issues. I will talk about climate risk management. I'll talk about climate finance, some other things. It's not really a course, or this is not a lecture on environmental science. That's a different topic. It is about environmental finance and some related social issues and how finance is addressing that. And I will start with it. I will be focusing mostly on climate finance, but what I want you to learn can be generalized to other areas in social programs that governments have. So when it comes to climate finance, I like to start with a quote by Mark Carney. Mark Carney happens to be the Prime Minister of Canada right now. But he is the only living person who has been the central bank governor of two different countries at different times. Bank of Canada first, and the Bank of England. So he has a very broad perspective on banking, how banking works in the financial sector. He has also been the special envoy for climate action finance at the United Nations since 2019. And he is talking about climate change as a factor that is creating, on the one hand, damages, but on the other hand, it's creating opportunities. And it's the opportunities that I want to be mentioning today in my course. I like to quote three people who are very prominent in this area. The first one is the Chief Executive Officer of the University Pension Plan of Ontario. So she manages my pension. She's a very well-known investment professional here in Canada, Barbara Swan. He's very vocal in everything that I'm lecturing today. She says that our financial systems can and must play a critical role in financing Canada's transition to a climate-resilient net zero future. That's what she says. Okay. The other person that I like to quote is Jamie Dimon, the chairman of JP Morgan. He says immediately actionable opportunities in relationship with climate goals might require more financing, not less. And this is a very interesting quote because it talks. You can see what he's addressing in his statement. He's addressing the banking business. It's going to require financing, and that's why JP Morgan is going to be there. That's the way I read it. And because of that, you're going to see that more and more financial players will be there. And the CEO of a Canadian bank, Canadian Imperial Bank of Commerce, CIBC, Victor Dodig, he says banks and our clients focus on commercially viable solutions. The economics of change and sustainability need to work, which they do when they're constructed in the right way. So this is a very interesting quote. On the one hand, it mimics what Jamie Dimon is saying, that if there's business, the bank has to be there. And he's also pointing to the fact that these things will work when they're done right. Okay, if they're done wrong, they will not work. So with statements like that, it's very hard to disagree. And this is just what banks do. If there is financial activity somewhere, they go there. And this is independent whether you agree or disagree with that financial activity. In this course, I'm going to be addressing some of those things, and many of the things that I will be talking about go back to two very important meetings. One is in Kyoto in 1987, and the other one is in Paris 2015. We're actually exactly 10 years since the Paris Agreement. And I want to give you an overview of what happened there and why that's relevant for you as future participants in the financial sector. So Kyoto 1987 created an economic incentive to reduce emissions. I was around at the time. I was participating in some of the conferences, not in the Kyoto discussions, but some of the conferences that were generated around that. And what I remember from 1997 is not much was known at the time about climate finance. We had not developed some of the databases that we now have that help us understand what's happening. Many, it was in the early days, but back then there was already the discussion that if we want to, if say air quality is important to us, then we need to recognize that there are countries like, say, Brazil, because they have the Amazon forest, that contribute to air quality around the world, and right now they do it for free. So if we want them to continue to do that, maybe it should not be for free. Maybe they should be compensated. That was the the discussions back in the 90s, that led to the Kyoto discussions. Some of those things have been done, but not very much has been done. Then, of course, countries, Brazil in particular, they've been encouraged to turn their Amazon forest into something else that creates them a profit, because it is perhaps not a profitable enterprise. So something was created, and I'll explain to you a little bit of what was created back then. But that was the consensus back in 1997. We should not consider air quality to be something that is just free, because if it's not costed correctly, we will probably lose it. The Paris Agreement of 2015 went beyond that, and what it did is it created a worldwide program to reduce CO2 emissions, to get countries to stay within certain limits over a period of time. It was ratified by all but 6 countries. I forgot which ones they were. Countries that are somehow irrelevant for the significance of this agreement. Of course, now, as you know, the United States has left, Argentina has left, so the Paris Agreement is not what it used to be 10 years ago. That's not going to be a big concern for us. We're not talking about that today. What I'm talking about, the finance of all of that. And in particular, what's relevant for us is Article 2.1c of the Paris Accord, which states, as part of the accord, that there's an intent to making finance flows consistent with the pathway towards low greenhouse gas emissions and climate resilient development. What that means is, and this is the reason that this underlines the statement by Jamie Dimon that says, or even Victor Dodek, that says that if finance flows are going to go there, the banks have to be there. This is what 183 countries decided that was going to be the case in 2015. And it's because of that it is important for all of us to be aware of what climate finance would be and could look like. And that's the purpose of my course today. That's what I'm going to be talking about. There is a related um, um, there's a related concept to climate finance, and that is the concept of ES and G, which I will also explain today. And ESG stands for environment, social, governance. This is something that goes beyond climate finance, and this is something which is very commercial, very, very commercial. In fact, so commercial that to this date there is over $1 trillion a year in ESG labeled bonds. We've talked about bonds in this course. We have not talked about ESG labeled bonds. These are bonds which are issued to fund initiatives which are consistent with the United Nations Sustainable Development Goals, which I'll explain today. So there is a part of finance which is growing fast. $1 trillion a year is bigger than most countries. Okay, so that's a huge. And so this is why it's important that we know all of these things, because these markets are significant. We saw a big increase of that during COVID-19, but that was just a coincidence because this thrust really started about a year before, about 2018. Okay, and a year ago there was more than $30 trillion in ESG funds worldwide, and $30 trillion, that's about the size of the United States economy. That's a very big deal. Yeah. So these are the reasons why we need to know these things, and that's where I will mention a few things that could be useful to you. This is another development. The Securities and Exchange Commission adopts a rule to enhance and standardize climate-related disclosures for investors. When the SEC does something, the SEC is essentially the customer protection agency for financial products in the United States, essentially. So when they step in and do something, is because these things are growing to the point that they deserve attention of the regulators. So that is again consistent with what I'm talking about, that these things matter. All right, so this is why I'm talking about this. This is relevant. Now let me talk about what it is that I'm talking about. And for that, I want to start with something which is unrelated to what is happening today. In fact, goes back a long time. At that time, it had a name. It was called responsible investing. And I want to refer to an article in the New York Times of May 24th, 1990. And this article talks about how Harvard University Endowment, I think it's called Harvard Investment Management, and the University of New York have announced a plan to get rid of their tobacco stocks. Okay, so this is not climate, this is not about sustainability, it's about tobacco. Now, I'll give you a historical context for this. Tobacco stocks in the 80s were the most coveted stocks in the world. All companies wanted to own tobacco companies. Tobacco companies were very profitable. They produced products, cigarettes mostly, that were very cheap to produce and sold at a very high premium. The sentence that was used is, you make them for a penny, you sell them for $1. That's 100 times a multiplier between the cost of production and the revenue. So, and hedge funds were after that. Food companies were after tobacco stocks. It looks like tobacco stocks was what everybody wanted to have on their portfolio. They were the most profitable. They were like the tech stocks of the time. What AI stocks are today, that's tobacco stocks in the 80s. Then suddenly these two investment corporations, Harvard is the largest university endowment in the world. Today is about $35 billion or something like that. It's a very big number. They decide that they're going to go against that. And why do they do that? Well, they do that because they say tobacco companies are bad companies. They kill their clients. We don't like that. That was the stated reason. We're going to mention that there could have been other reasons. I don't know that this is their driving decision, but that's what they said publicly. And because of that, then we don't want to invest in them. At this point, this could give rise to two types of reactions from the the constituents. These are the people who are running the pension or running the fund, or the people who benefit from it, which are the people in the university. One would be to say, this is good, this is socially responsible actions, and therefore we support it. Or you can say, no, we don't care about that. Our job is to just make money, and how we do it is not our concern. This could have been two perspectives. They chose the first one. They chose to have a socially responsible investing, which is again consistent with what I'm talking about today. I'm not getting into whether this was right or wrong, but I want to give you a historical reflection on their decision making. The historical reflection is as follows. I went back, I did this graph myself. I went back to May 1990 when this decision was made. And I have here in front of you two charts, one that compares the performance of the S&P 500 index as a reflection of what you would do if you just invest in the markets without thinking. And the other is if you invest in a particular tobacco stock, the one that I could trace the price back to 1990, and that's British American tobacco. So if you do that, what do we see here? You just go through this graph. You see that the S&P seems to do better in the early 1990s up until the year 2000. So it seems that they were right. You could think that. Then you can see that the dot-com bubble bursting made the S&P go down, and then that allowed the British Tobacco Company to reverse its course. Then you can think, oh, they were wrong. It was a better idea to invest in tobacco stocks than the S&P 500. Again, I'm ignoring the social issues just from a financial perspective. And everything was like that up until 2018, more or less. In 2018, something happened. What happened was a number of different factors. On the one hand, by the way, tobacco stocks had been the source of lawsuits, numerous lawsuits, because of that. And that happened after this decision was made. So in the 90s, in the years 2000, 2010, lawsuits on tobacco companies have been everywhere, especially in the United States, and they systematically lost every lawsuit. On the one hand. On the other hand, there was competition from alternative products, as you know, vaping, and decreased demand, especially in North America, but maybe worldwide too. People are beginning to smart up and to make it a decision to stop smoking, so there's less demand for their products. And then, of course, regulation that increases the things that they need to do and this and that. Okay, so this, but the big thing for me, I think, I mean, I don't have proof of that, but what this is consistent with is something else that happened, which is a social trend. In 2018 is when investors in North America primarily, and in Europe, not around the world, just there, they started to demand from their investment managers a more responsible approach to investing. It was codified through this ESG approach that I mentioned earlier, and this started to affect a lot of these companies. Now, this may look like a long time. We're talking about a period of 30 years from when the decision was made until when you could think that the decision proved to be the right one. Okay. But 30 years for a pension plan or for an endowment is not a long period of time. These are companies that need to invest for the long term, very long term. 30 years, maybe 100 years is sometimes not even a long time. So this is, I think, a good example that although it talks about tobacco, it's a very good example that gives the framework on which ESG was created. I have here for you, I'm not going to play it. You can watch it yourself. It's in this clip is in my YouTube channel. This is what Harvard University looks today. There are protests. There have been protests where the constituents of the Harvard community are urging their investment corporation to divest not from tobacco anymore, but from fossil fuel companies. Okay, so again, I'm not going to play this video. You can watch it on my YouTube channel. But what this does is it sets the tone for how investing is today. These are things which affect companies. This has been nowhere in any of the models that we have developed in this course. It is something that I'm just going to mention today to increase your awareness of something which is developing. It's been there for more than 5 years now. It's growing, as I mentioned earlier. But I also want to see when it comes to, I like to talk about this as social finance, more than climate finance or more than sustainable finance, social finance, because this finance is created, or these financial flows are created not through accounting reflections, but through social awareness. And when it comes to social awareness, suddenly new things come into play, and behavioral finance is a very important part of that. So to show you how this is very relevant and something that is not to be ignored, I have this. It's a very well-known game. Maybe you've played it before. It's actually two games, and I'm not going to play. I already know what your choices are going to be. If you in the first game, if I give you two choices, in the first one you're just going to make some money for sure. You make $900 and you go home, or you take a different choice, which is you can gamble. You can earn more money with a 90% chance, $1,000, or you can go home with nothing at a 10%. The expectation of this game of choices A and choices B is exactly the same, yet most people choose A. Very few people choose B. When I do this with large audiences, about 90% of the people choose A and about 10% of the people choose B. Maybe it's because they like gambling. I don't know. I don't have a chance to ask. But typically, everybody prefers the safe choice. And in game two, what I do is I reverse the outcome. And I say, in your first choice, you're going to lose money for sure. You pay $100 and you go home. And the other is you gamble. And if you gamble, you can lose more. And when you present this game to people, everybody or most people like to gamble. Okay, so this is how humans react to both gains and losses. When it comes to gains, we like to lock them in. We don't like to gamble. But when it comes to losses, we like to gamble. And this is going to have important consequences to how we act and how markets work and what we do about that. This increases the need for something which I like to call risk thinking. When you do risk thinking, and let's think how the tobacco companies might think about risk. The tobacco companies signify profitability today to investors. Okay, so that was in the year 1990. But it would also present risks for the future. And we don't know the extent of what those risks will be. We do know that lawsuits are possible. We don't think that shareholders will be impacted by those lawsuits, but you don't really know. If there are cases where their responsibility, the social responsibility, has been pushed all the way into the financial backers, sometimes even to the boards of the companies. So we don't know if that's going to be the case. So we're dealing with uncertainty here. And if you price this uncertainty, then perhaps this was the right approach. The price of risk and the price of time, when you balance the two, they may give rise to a different optimal decision. We've already seen the price of time in this course. We have seen a little bit of the price of risk. This is how we priced uncertainty, and you can even argue that the Block-Scholes theory is a way to price risk. So when you balance the two and you take into account risk that comes not from uncertainty in stock prices, but the possibility of lawsuits, then you may take decisions differently. And if you go back to the two games that we played earlier and you come up with a price of risk in that situation, then you may also come up with a different context. So this gives rise to this thing called impact investing, which is to have a general awareness of the consequences of one's actions. Again, this is the main reason why I wanted to end this course with this lecture today, because this is something which has never come up in our discussions so far. Every methodology we have developed has been rooted on some numbers. We have not introduced social elements into that, including, by the way, the fact that the way communities think tend to affect prices. We did talk about GameStop at some point, and for me that's a very good example of modern finance, where collectives can decide what the price of assets will be. And then if that's the case, then you cannot ignore it anymore. It has to be part of what you take into consideration. But this became ESG in the 2018 area, right? Which is something that the ideal is that it gives rise to well-defined rules and procedures in place. So we have the right outcome. We're not there yet, but maybe we will be there at some point. And this is what I like to call sustainability or sustainable finance. Okay, all right. So that's the framework for what I will be discussing today. And there's going to be a lot of risk thinking today, risk which is no longer going to be restricted to quantities such as value at risk or credit value at risk or some of the risk measures we have seen in the past. I want to take risk in a much more general context today because this risk affects social decisions and related facts. And for that, I like to use an example. The example that I like to use is some people are afraid of flying. So let me take that as a way to think about risk. This is not something we can quantify, so I think it gives me a very good, a neutral platform to talk about risk thinking. There's a law everywhere in every country that says that if you have a thunderstorm in an airport, the airport needs to shut down until the storm is over. Thunder and lightning causes airports to close. Now imagine that that's not the case. Imagine that you are at an airport, you're about to board your flight, and well, you see the picture there. You have a big storm, and you don't have a choice. You have a choice, which is you can board the plane or not board the plane. But if you do not board the plane, then there's no refund, there's no cancellation. You just lose your ticket. Okay, so the question is, will you fly? Will you get onto that airplane? So when I ask this question in large audiences, most people don't board the plane. They don't mind losing the price of their ticket. Okay. So you notice that this is the same game as we played earlier, except in this case, we're taking the opposite decision. In this case, we prefer to lose money as opposed to gambling. Okay. Let's go through some arguments in favor and against. Arguments in favor is probability says that you're unlikely to have a problem, so why are you worried? Okay. In fact, physics says that if lightning hits the airplane, it's going to go around the plane and then hit the ground and you're going to be fine. And Faraday law says you're going to be safe. The argument against is that if you're wrong, if something happens, then you die. And this seems to be what prompts people to making these decisions. Okay. So this is an example where the result of the previous game that I mentioned earlier changes. So let's look at this from a dispassionate perspective, and let me introduce the context for risk thinking, which is what to do when you don't know what will happen. By the way, this is, in a certain sense, what we have been doing in this course very often. To think of what to do when we don't know what will happen. It's just that in the past we were given a framework, typically a quantitative framework, and now, well, we probably don't have it. So we already saw an example of the snow swap where this was already there. So let me bring the snow swap back into my consideration by putting that into the context of what we're deciding here today. The ski resort could have decided to not gamble and then just um, collect all of their revenues, or they could have decided to gamble. And in the case that there's snow, they make a lot of money. And in the case that there's no snow, then they make no revenue. So that's how the decision of the ski resort could be from the perspective that we're developing today. And the city of Montreal, when we saw their interest in the snow swap, they could have decided to not gamble and just pay the premium, or say, well, you know what? No, I'm going to gamble. I'm going to take my gamble, and if there's snow, I'll lose a lot of money, and if there's no snow, then well, I don't lose anything. So you see, we can put the decisions within this context. The interesting part here, and I mentioned this just in passing, is the financial intermediaries. What they can do is they can make people change their mind. In particular, in this case, you see, the ski resort did not really have much of a choice, neither did the city of Montreal, until we showed up and we gave them a swap. When we gave them a swap, that suddenly changed the cost balance of these two decisions. And if the cost is right, then they would enter into the transaction. And by doing that, we earn a fee. As a financial intermediary, we earn a fee. Financial intermediaries earn fees. They don't gamble. They just make money, for sure, like we did. In this case, there was a little bit of a risk because we had to choose two different measuring stations, but we went through that and we know how to handle that risk. Okay? But this is how finance happens. So you could think of sustainable finance. In particular, you could take the comment by Jamie Dimon as to say, this is happening. I can put my bank's business in the middle of this, and I can basically make gamblers gamble with each other, and then we collect a fee. So that would be a perspective that we can do on that. Now, to understand how you do what you do, it's important to organize the information into three buckets. The first bucket is what's called the known knowns. These are the things that we know. Then we have the known unknowns. These are the things that we want to know but don't yet know. For example, we know that the stocks have volatility and they could grow or sink. Okay? And then you have the unknown unknowns, the things that we're not aware of, things that we don't know that we don't know. Okay? This concept was very well presented by Nassim Taleb in his book, The Black Swan, and he presents the case of a turkey. How would a turkey think of itself in November? For this, I need to give you some context, which is November is when American Thanksgiving happens, and in American Thanksgiving, people eat turkey. So that's the context for that. So he uses that in his book. So if you're a turkey and you are in early November, then what are their known knowns? You had a good life. There's always food. There's always home. You're happy. You're just living your life. Okay. The known unknowns is that you don't know how that's going to last, but things are just stable for you. And the unknown unknowns that the turkey has no idea that Thanksgiving is coming. And that's how he presents that. I could put this in the context of the Silicon Valley Bank that we also saw in this course. The known knowns is that rates are low, we have lots of deposits and excess cash, and we invest in the lowest risk investment possible, bonds. That's what you know. What you don't know is when will rates go up. If rates are at zero, at some point there would be above zero, which means that bonds will decrease in price, and then I know I will be in trouble if and when that happens. And what will happen to my deposits? I don't know. They may decrease, maybe they increase. We don't know. Okay, so these are the known unknowns, and these are things that you can think about. And then the unknown unknowns is that who would have thought that rates go up by 5% at the same time as my deposits decrease? Okay, you can imagine that. So that's how you organize the information. In fact, if I go back to the snow swap, we were victims of the same unknown situation when we saw that IntraWest was going to file for bankruptcy, and we had no idea that IntraWest was the company owning all of the ski resorts that were parties to our snow swaps. See, this happens all the time. And these are things which are very hard to account for, very hard to but we can account for the known knowns and the known unknowns. When it comes to the snow fund, we could organize the information in the same way. Snow in cities and mountains is similar, we know that. The unknown unknowns is that they're not exactly the same, so they could actually create differences in precipitation. And we had a way to handle that. That's why we diversified our portfolio, and we saw that with a properly diversified portfolio, the risk that the differences in precipitation would be there didn't really matter to us. We still had a very good investment. The unknown unknowns is the default. We were not aware of that. So this always happens. We always need to understand the information into these three silos. Now, let's talk about climate risk in 2025, 24, it doesn't matter, 23. The information we have about climate risk is as follows. Today are things that we know. We know that CO2 gets warm with the sun rays. Strictly speaking, it's not the sun rays, it's the sun rays that hit the earth and then they get reflected back. They end up having a wavelength that makes the CO2 molecules spin very fast and therefore they get warm. Okay? Methane does it too, actually even faster. NO2 does it too, even more. And H2O does it too, even more. These are things that we know. So we know that the fact that we have the sun makes these gases, these four gases, get warmed up. And these three more. Okay? But these are four gases which are naturally produced. There's no way for us to get rid of them. In fact, we need a little bit of CO2. If we didn't have CO2 in the atmosphere, the average temperature of the Earth would be 18 degrees below zero. So Canada would be very, very, very cold country under that. So we do need these gases, we just don't need too many of them. Okay, if we have too many of them, then the temperature will go up. We know that from physics experiments. These are the known knowns. We've run experiments in our physics labs, and we know that whether we like it or not, these four gases will just get warmed by the indirect effect of the sun. Therefore, we would like to keep them constrained. Why? Because we have the known unknowns. There's things that we don't know that we know we don't know, and there's people modeling that. Will this really create the atmosphere to warm up? Well, most likely yes, but who knows? Maybe not. Maybe this creates a very strange atmospheric effect and increased cloud cover. Who knows, right? We don't know. People are running simulations, but there is a probability, a significant probability that this will give lots of problems. It could create weather volatility, wind, rainfall, etc. It could cause the polar caps to melt. It could reverse the Gulf Stream, which would be a disaster, okay, a climatic disaster. These are things which the probability is reasonable. It's a reasonable rate. And then on top of that, we have the unknowns that we don't know that could happen. That's how we organize the information. So from a climate risk perspective, these things, they do look like they are things that we should be taking care of that. If I go back to my thinking of the airplane taking off, it's very similar. It's a very similar consideration. There's a 100% chance that I lose my ticket if I just don't board my flight, or I can gamble. And suddenly, when it comes to climate finance, it's all in the premium. You know, why do you do what you do? It's because the fear of dying is perhaps higher than the fear of flying. Okay, and I can go back to our game, and then I'm going to now change the numbers in my game. And if I change the numbers, I change the numbers ever so slightly. So people will probably continue to make the same decisions as before. But now, what we have is the ability to enter as financial intermediaries and trade between players of game 1, choice B, and players of game 2, choice B. But we need to price the risk. How do we price the risk of that? And the way to price the risk is as follows. When you go to the insurance sector, the action taking option of of choice A, I take action. That is gonna, in the case of gain B, it's gonna cost me money. So I take action at some cost. You could think that this is me taking climate action, which is gonna cost me money. But I'm still gonna do it because choice B is worse for me. When you do that, this is the mitigation cost, or in a context of finance that we saw earlier, is the option premium. That's if you take action. If you don't take action, you're gambling. And if you're gambling, there are two things that matter. One is the loss value, how much you can lose, whether it's your life or whether it's $100, that's your loss. And then the loss probability, how much do you expect to lose? So this is something which we already have seen. We know how to deal with this. In fact, I want to bring back now something I hope you didn't forget, but there was the Wahl's equation or Wahl's equation when we looked at compound Poisson processes. That's going to become very relevant. Mentioned it when I talked about that. I'm going to mention it again. So if you don't know what I'm talking about, you'll have to go back and consult the notes. So, because to calculate the insurance premium, what we need to understand is the balance between these two numbers. Whether we do choose A or B is a function of these three variables: the mitigation cost and the loss value given the probability of loss. How do you bring these things into account? So let me reflect on that a little bit. Let me talk about a rational risk theory, some basic facts, okay? One might think that the insurance premium should be equivalent to the probability of loss times the loss amount. One could think that. The answer is that's not true. Let me write down what this means. If I have scenarios XP with probabilities P leading to losses LP, okay, so I'm giving you the framework which is consistent with our probabilistic definitions. In this case, I'm taking the simple approach, which is the discrete probability approach. You could do this in the continuum case. Then it's perhaps replacing some with integrals. It may be more counterintuitive. This is good enough for me, so I'm going to take the discrete approach. It's fine. I'm going to take scenarios XP with probabilities and losses. So we now have a probability space which consists of probabilities and the losses are given by random variables defined in our my sample space. And we saw all of these formalism earlier. So is the insurance premium proportional to the expectation of the losses or not? So this might be true when risks are diversifiable. If they're not diversifiable, this is not the case. But even when they're diversifiable, this is not the case. In fact, I remind you now that when we saw Wahl's equation, we saw that the expectation of losses, when done right, it contained the expectation of each individual claim. It contained the expected number of claims, but it also included the variance of the number of claims, multiplying that appeared in the calculation of the insurance premium. So we already suspect that there's something more to this than that. So for that, what I'm going to do is I'm going to give you, we're going to think of the risk pricing using auto insurance as an example. I'm going to develop the theory of risk, the rational theory of risk in the case of auto insurance, so we understand what we're doing quantitatively. So let me give you the assumptions. The assumptions are, I have the expected value of an auto claim is $1,000. And the probability of an accident is 10%. Okay, so I have an expected number of claims, which is 10%, and the expected claim is $1,000. I remind you, this is a compound Poisson process, and we know how to calculate the variance and the expectation of this, right? And one claim is $10,000. I'm going to make it easier. If I introduce a volatility in the $10,000, then I'll be using Wahl's equation. If I do it like this, then it's a very simple probability factor, but it's going to be, the considerations are very similar. If I have no diversification, if I sell a single policy, what happens? The loss function is now a Bernoulli random variable with a mean 1,000 and a standard deviation of 300. You just calculate. Okay, with the numbers that I gave you, this is the answer. What does that mean? Well, let's say that we charge $1,000 for the policy. If you charge $1,000 for the policy, there's a 10% probability that I get a claim. And if I get a claim, the game is going to be $10,000, so I'm out of business. If I sell a single policy, I cannot charge $1,000. They say 10% chance I die. Could I charge $1,100? If I charge $1,100, I can see that with almost the same probability, I'll still go out of business. Because I only have one. And the probability that I get a claim is 10%, is very high. And if I get a claim, it's much bigger than my revenue. Imagine that I do a diversification, a good diversification. Let's say I sell 1 million policies, and they are independent of each other. If I sell 1 million policies, the loss function would be a Bernoulli with mean $1 billion, that's 1 million times 1,000, and standard deviation 300,000, because the standard deviation grows like the square root of the number of policies, so it grows like the square root of 1 million, which is 1,000. So 300,000. So can we charge $1,000? No. If I charge $1,000, there's an even higher probability I go out of business. 50% chance I go out of business, because that standard deviation would just kill me, right? But could I charge $1,100? The answer is finally yes. That is good. That I can do. Because then the probability to go out of business is less than 1%. It's very small. Okay, so what we learn from here? So we learn a number of things. First of all, we learn that diversifiable risks and non-diversifiable risk are priced differently. We learn that diversifiable risk could be cheaper. We learn that non-diversifiable risks are more expensive. Climate is a non-diversifiable risk, so it's more expensive. Therefore, we should be willing to pay more as a premium for that. And this is perhaps the justification of decisions such as the ones in the Paris Accord. Okay. Now, the way you would price risk, taking into account what I just mentioned, is if we're seeking protection against losses given by a random variable, then we should expect the cost to be of the order of the expected losses times a premium paid on the risk which is not diversifiable. So this is pricing undiversifiable risk. Similar to the outcome that we get from Wall's equation that tells us that the risk is really a combination of the known unknowns and the variation around that, around the uncertainty in the number of claims we can get. In other words, the insurance premium should contain the expected loss for sure, but then a percentage of the standard deviation of the loss functions. And note that this is how we priced our credit trade when we did credit risk. Okay, so now the course is, I think, wrapping up nicely. All of the things keep coming up, and many of the same features that have come up in the past keep coming up now. Okay, so this is what gives rise to or justifies the investor's approach to impact investing. So impact investing aims to generate specific beneficial social or environmental gains in addition to financial gains. And this is now, so I can now, we've given the mathematical framework to understand this. Let me give you the social framework. The social framework stems from the Sustainable Development Goals of the United Nations. The United Nations, 193 countries, got together over 10 years ago, 15 years ago, 20 years ago, to decide what are the objectives that the world should aim for. And they came up with 17 goals. I have them here. No poverty, zero hunger, good health, quality education, gender equality, clean water, affordable and clean energy, this and that. You have them written there. And these have become the objectives. So if you're a bank, like Jamie Dimon said, if these are the objectives, then I'm going to go there with my bank and I want to become the financial intermediary to make these things happen. And we've developed in this first half of the lecture today the framework to go and do that. Okay? What I want to do today now is I want to give you some examples of what actually happened. If you're an investor, then you're going to be on. If it's your own money, you're going to perhaps going to be going to take advantage of this drive to sustainability. But if it's not your money, if it's your client's money, you'll have to take your client's opinions about this, and that's why the ESG business developed. Okay, so I have another video explain this. I'm just going to move on. So this is what gave rise to the ESG labeling system. So these sustainable development goals are translated into three pillars. The E pillar, which has to do with environmental objectives, the S pillar that has to do with social objectives, and the G pillar has to do with governance related objectives. Okay, so I have the contents there are not particularly, they're common sense. And this has been created alongside the creation of a global climate policy group. The most important one when it comes to climate finance has been the Intergovernmental Panel on Climate Change. Then you have the Financial Stability Board, both of which have said that greenhouse emission levels must be reduced by on all global constituents. I'll tell you how this actually is being developed. Okay? And this has to be something that affects all the actors in the economy that participate in that. Whether you're a direct emitter or whether you're a financier of an emitter, whether you depend on energy systems that give rise to greenhouse emissions, or whether you produce products and services to those who produce the emissions. Okay, and the emissions. I'll just give you this. This is a physics lecture now. There are 6 emission gases which are the targets: carbon dioxide, methane, nitrous oxide. These 3 are natural created hydrofluorocarbons. These are made by humans only. Perfluorocarbons made by humans only, and sulfur hexafluoride made by humans only. So the first 3 are natural. The 3 last ones are made by humans only. But notice that water has been removed from here, H2O. And the reason for water to be removed, although it's a very potent greenhouse gas, is because the amount of water in the atmosphere is controlled by itself. It has a half-life of about a week because it rains. That we don't have that with carbon dioxide, methane, nitrous oxide, or any of that. They stay in the atmosphere for a long time. Carbon dioxide is there for over 100 years. Methane is there for over 30 years. After 30 years, methane oxides and becomes carbon dioxide. But for 30 years, it's warming up the atmosphere at a very fast pace, about 80 times bigger than CO2. These things are measured with this thing called the global warming potential. It tells us, compared to CO2, how does this microwave activity warm up the gas. And so CO2 has a factor of 1 and is in the atmosphere for over 100 years. Has a very big half-life. As I mentioned, water is not here because it has a half-life of nothing, a week, so it rains, right? So the levels of humidity in the atmosphere are more or less constant, high, but constant. And CO2 is produced in 2 ways. It's produced naturally through decomposition. The CO2 dissolved in the water in the oceans, and so on and so forth. And it's produced by humans through cement production, which is a very big producer of CO2. We need to heat up the limestone to over 1,000 degrees to create cement, and that is done by burning fossil fuels right now. So, deforestation, which is a natural way for nature to capture carbon, and that. Okay. Methane is produced also naturally through livestock, through digestion, through natural decomposition. Also produced by humans through oil and natural gas systems. When we produce oil and natural gas, we create methane that we emit into the atmosphere. It has an atmospheric lifetime which is 10 years. I said 30 earlier, no, it's 10. After 10 years, it oxides and becomes CO2. But the global warming potential until it does that is very high, is 80 times that of CO2. And that's why methane is a target gas. So is nitrous oxide. As you can see, it's even higher, a global warming potential of over 300. And an atmospheric life of 100 years is almost as long as CO2. So NO2 is very big. Nitrous oxide is N2O. Okay. And then the human-made ones, which hydrofluorocarbons, by the way, they've been outlawed, so we don't have them anymore. These are the ones that also create not just global warming, but they create the thinning of the ozone layer. That's why we're not hearing about the thinning of the ozone layer anymore, which was the topic of conversation when you were babies. We don't have that anymore because these have been outlawed, and the ozone layer is coming back, which gives us very good protection against another thing, which is this sun radiation. But you can see the lifetime in terms of years, 3,000 years, 1,000 years long, and the global warming potential to be 10,000 that of CO2. So even if you release a little bit, it has a very big impact on the increased temperature of the atmosphere. So these are things which are known. These are the known knowns, right? And then who contributes to the greenhouse gas emissions? So these are organizations with the emission generating industrial processes. All the environments that consume energy and heat, like for example homes or the building you're in right now. Power producing groups that supply energy. Food and agriculture industries, which also produce emissions. And I'll come back to this in a minute. It's a very important part of the emissions. And here there is a table which is very often referenced when it comes to the contribution of countries to greenhouse emissions. So, on the narrative here, now some math is coming in. This is going to be a very interesting use of math that we're doing now. So the country that emits the most is China. China has the biggest emissions. It's about 10 gigatons per year. Okay, and in certain groups, China is referenced as the big emitter. It's interesting that Canada is number 7. I just mentioned that name there. Okay, Canada produces over half a gigaton of CO2 emissions per year. But then the argument that is oftentimes countered here is that if you order the countries not by their absolute emissions, but the emissions per capita, because China is a very big country, but there's a very big population, then you see the population emission of China is 7 tons per person, which in the United States is twice that, is 15 tons per person. So to one argument is a counter argument. So if you order the countries on the emissions per capita, then suddenly this relationship is changed dramatically. Of course, suddenly the small countries come up, because the countries that are small, they have a very small population, and the country which is interesting in the per capita is Canada again, which also stays at number 7. And the reason that Canada is such a big emitter is because of its two things. It's agricultural. We're an agricultural country. We do produce oil. We do produce pulp and paper, and we do have mines. But Canada is preeminently an agricultural country. And when you take the emissions that come from activity and related to the population and divide by very small population, Canada has a very small population, then of course a big number comes up. And this is a very nice mathematical challenge, one that I decided to take personally, and I've done some research on this. And I want to put it in the context of what we have learned in this course, in other parts of this course, which is how do we do factor analysis of that? Which of these two graphs, which of these two tables is correct? Clearly not the one on the left, because it does not account for the population that is giving rise to that. After all, countries are just, from a climate perspective, random organizations of people into groups. Clearly also not the one on the right, because the one on the right does not take into account the relationship between emissions and people. It's just something that contains lots of other factors hidden there. And here I like to quote a very well-known mathematician, Paul Erdos, who has a sentence which I like very much. He says, a mathematician is not someone who knows how to add, but someone who knows when to add. And you can take this beyond adding to subtracting, multiplying, or dividing. Okay? And the thing is that in this case, the reason these two charts have become popular is because people can at most multiply. That's all they can do. They cannot do anything else. But now you can, because we've been taking these courses, and you're going to take more courses in your program where you can do much more than just add, and then you can find other ways of doing the rate analysis. So let me just tell you what this is. This is a research paper that I wrote with my students, Wendy Xie and Davis Lee. And these are to study emissions in socioeconomic terms. So this is also a very important part of finance. This is how you do the right factor analysis of emissions. What we did here is realize that population is not the only factor that matters. There's other things that matter, like for example, surface area, or for example, GDP, or for example, how many people live in cities, or what's your electricity production. See that we found that there's 6 variables that matter, not one. Therefore, you cannot just divide by one. Dividing by one, it means that you ignore the other factors. And we did this using support vector regression, by the way, which is something that is a technique from machine learning that will be seen in the next course on machine learning and data science. Okay, so this is an application of that. So this is an early example of something that will be coming in a different course. But when you do that, then you can come up with the right factor analysis, the right comparison for what each country should look like. And then you can do it. What we did is we did a very nice, I like this very much, that's why I like to talk about it. We analyzed the country's emissions in the context of their socio-economic, geographical terms. And this is what we found. We found that when you take the difference between your actual emissions and the emissions given by these benchmarks, which are constructed using support vector regression, using machine learning, what we see is that some countries are becoming browner, their emissions are going up with respect to their baseline, and others are going greener, their emissions are going down with respect to the bench. And so this, for me, it was a very reassuring activity. Of course, no one takes this into account, but at least the paper is there and we have a framework to do this. And why is this important? This is important because I remind you, the Paris Accord was an agreement between 193 countries to set their objectives for the next 20 years. But back then they did not know how to do this. In fact, today they are still arguing as to what the objectives of each country should be. So the objectives were decided through a very intense and fairly violent negotiation agreement between the different countries. There was no benchmark. And I like this because it gives you a benchmark. But now I'm going to go back to the previous agreement, the one that I think is actually perhaps even more interesting than Paris, which is Kyoto 1997. And what Kyoto 1997 did is created a platform for the trading of emitters and capturers of CO2. And every time you have a project, you have to analyze whether you're emitting CO2 or you're subtracting CO2, and then you'll be compensated for that. And I have a business case here, which is one of my favorite business cases. It has to do. It's a case done in Kenya with a Dutch company. So let me tell you about this case. It's very interesting. It's the case of a company called LifeStraw. It's a product called LifeStraw, created by the company Westergaard. What they did is they brought 800 almost a million water filters to Kenya. And I want to show you the economics of this. The finance of this is very interesting because in Kenya, the way to produce drinkable water is by burning wood. And then what they brought is these filters that does not require that you burn wood to collect your drinking water. Okay, so because of that, and I'll explain to you how this is done. Because of that, their product is saving almost 3 million tons of CO2 per year. That's good, but it's not only good. This is something which, according to the Kyoto Protocol, should earn them some revenue. In other words, companies that emit CO2 can purchase the credits offered by this product so they can lower their credit emissions. And this is something which is consistent with the Paris Accord. This was created in Kyoto in 1997, and then the Paris Accord gave the framework for these things to happen. And just to give you an idea, the price of a ton of CO2, the unit is CO2e, that's a ton of CO2. The price of CO2, depending on where you sell it, it could range from $10 to $30, maybe $100. So at the lowest price, this gives this company cash flows of $27 million per year. This is the new finance. Because of this company has an additional revenue of $27 million a year if they sell this if they sell for $100, then it'll be $270 million a year. So this becomes a new financial variable. This is the one that the Securities and Exchange Commission was recognizing as the new product to come. And it's still not there, still not universally accepted, but it is gaining ground very quickly. And who knows, in a few years, a course like mine would be incomplete without going through, but only talking about stocks and bonds and futures. Maybe you should be talking about these new instruments, which are driven by sustainable or social issues that financial participants can buy and sell. Okay, so this is an example of that. It's a bit of science fiction, but as you can see, it's real. It's already happening. Okay. Now, I have another example of that. This is my favorite example when it comes to that. And all of this, as I said, is Kyoto 1997. My favorite example is a different one. Is one which is done in Australia, in the county of East Kimberley. It's this right there in Australia. In northwest Australia, there is an area where it's a savanna, part of Australia, and what is documented, what is known, is that savanna fires in this part of Australia can be very vicious when the savanna burns in the dry season. The dry season is between August to December back there. That's their winter. Um, if the land isn't managed, then these wildfires can burn intensely at scale and over long periods of time. By the way, these fires is something which we experience in other places. Last year, there was a lot of talk about this in the United States, and the year before, there was a lot of talk about that in Canada. We had a very big sequence of wildfires. Okay, wildfires, they occur naturally, okay, and sometimes you can do something about them, sometimes you cannot. But in this case, they were able to do something about that, and what they did, and I want to show to you, is again a new financial product, is very interesting. What they do is they do the following thing. They created a new corporation. It's called the Nyaliga Corporation. They created that in 2017. The purpose of this corporation was to manage the savanna fires by doing controlled burning. Controlled burning is they study where they do preemptive burning of the savanna. They burn it on purpose with the expectation that they will avoid the fires. They burn them at the right time to avoid the vicious fires that will happen in the dry season. So that's what this corporation does. It's a corporation done just to burn the savanna preemptively. And that's their business, controlled burning. And now this is the interesting part. The interesting part is this controlled burning activity has the following consequences. The area that is burned is decreases. The grass and wildfire are coming back, but this is just circumstantial. This is nice. But the CO2 emissions are documented to be 40% less than the uncontrolled burning. Because of that, this Nyaliga Corporation gets money from the Australian government. The Australian government has the Emission Reduction Fund, where companies can document. They apply first, they approved, and after they approved, they have to submit financials, as I'm about to show you. And when they submit the financials, the Emission Reduction Fund gives them money to compensate for what they have done. So this is interesting. It's consistent with what Kyoto did in 1997. And there are corporations like this one whose sole source of revenue is carbon credits. Okay. Now, how is this done? And this is the interesting part, and I will end my discussion today with this. What I have here in front of you is just some screenshots from the vast documentation which needs to be produced to make these things happen. So let me talk about that from a science fiction perspective. Let me talk about the future of this type of finance. Now this is science fiction. What you have on the screen is the analog of what companies started to do 100 years ago that we saw in a previous lecture. In the previous lecture, we saw the birth of accounting, trustworthy accounting, which happened around the time of the market crash. In fact, just after. It was part of the, I remind you that in our discussion of financial risk management, we saw that the market crash of 1929 gave rise to financial accounting that is trustworthy. That was revised after the Enron collapse in 2001 with the 2002 Sarbanes-Oxley Act. We saw that. This is at that level for a new type of securities that did not exist 50 years ago. 50 years ago, we did not have carbon credits. We have them now. In fact, the Paris Accord has established them not only them, also as a mechanism of trading. And in the previous meeting is called COP. The previous COP 30 was in Brazil just a few weeks ago. Prior to that, the previous COP was in Baku, and there countries agreed that to create a market of carbon credits between countries. So this is interesting because these are markets which are beginning now. On the one hand, you have trading within countries. We just saw this example here. That a legal corporation has a documented carbon reduction enterprise, and they receive funding from the Australian government in the form of emission reduction funds. And now countries can start to trade with each other so that if a country has difficulty meeting their targets, they can buy those credits from a different country that has extra credits to sell. And that's created an international market for that. How interesting is this? These things are happening. I have no idea where they will go. Okay, there's a good chance that these things are here to stay, but there's two lessons to learn from this, and this is what I want you to take as the last statements from this course. The first is we are in a situation where innovation is happening and new financial products are being created. But more important than that for you, I think, is look at the financial product we have here. To do this financial product today, you need to hire a team of essentially consultants and auditors that go through your Savannah project. They go around, they take pictures, they verify certain quantities. There's a lot of variables in the documents that I put here. And I only give you some screenshots. There's probably 200 pages of documentation like that. So you have to take all of that work, spend months and months and months working on that, spend hundreds of thousands of dollars to create this, which essentially is a tape of accounting. And both developments go hand in hand, meaning if you can speed up the accounting, you will speed up the trading. We already know that. This is what happened in the 20th century when accounting was regulated at the beginning of the 20th century. That created a massive growth to the stock market. And here we have something similar. It's just that the accounting is much more complicated. The accounting that was done for companies around the 1933 Investor Advisors Act was accounting of assets and liabilities. Many assets and many liabilities are accounted perfectly, others are not. Like, for example, the value of your data, there is no accounting for that. But in these new products that we have, in these new securities, the type of accounting that's required seems to be much more onerous. But my statement is the accounting is done wrong. This should not be done by consultants, this should be done by machines. And I think this is going to be one of the applications of large language models that will be coming. And this is your future. I think this is something that with appropriate technology, we're going to see that these financial products, these financial markets, these new financial markets are going to be able to grow. Volumes will increase, and very soon we'll have entirely new financial markets with its own characteristics, with its own players, its own participants. But I suspect everything we have learned in this course will continue to apply. Okay. So I end my discussion here. It's a bit of science fiction, but also a description of what's happening in the markets today.